Okay, number 4 is 4x squared plus 4x minus 15. There's no GCF between those three terms. So this is unlike the first problem where the coefficient on the x squared term was 1. The second problem, the coefficient was the x squared term was 1. And the third problem, I was capable of factoring out a 3 to make the coefficient on the x squared term to be 1. So I'm starting to think that maybe the AC rule might help me here. So let's write this down. The AC rule. What's the A? The A is 4. The B is 4. And the C is minus 15. So I want to put down A times C. Well, A times C, if I look at it, is 4 times minus 15, which is going to be minus 60. All right, kind of a big number, right? So I'm looking for two numbers that multiply together to minus 60, but those same two numbers, when added together, would give me the B, which is 4. All right? And something like that's really tough to think about, but not really. It looks like 10 and 6, because 10 and 6 differ by 4. So I'm going to say 10 and minus 6. 10 and minus 6. Let me just review that with you. 10 times minus 6 is minus 60, and 10 plus minus 6 is certainly 4. So let's write this down now. We're going to split it, and you're going to split the middle term. So it's 4x squared. I'm going to write down 10x minus 6x. I'm going to repeat this. 10x minus 6x is plus 4x. I'm going to factor by grouping. The first two terms, what I'm going to factor out is 2x. What are you left off with? 2x plus 5. From the second two terms, I'm going to factor out a minus 3. What are you left over there? 2x plus 5. What do you get over here? Well, the common factor now between those two terms is 2x plus 5. What are you left off with? 2x minus 3. All right, I realize some students may say, but if I did a different grouping, would I get the same answer? Well, let's go through it. You get 4x squared minus 6x, this is a different grouping now, plus 10x minus 15. Well, let's take a look. The first two terms, what comes out? 2x. What are you left off with? 2x minus 3. From the second two term, what comes out is 5. What are you left off with? 2x minus 3. What's common between those two terms is the factor 2x minus 3. What are you left off with? 2x plus 5. All right. Are we getting the same answer? We are. Now, some people claim, oh, you're getting a different answer. The order in which the factors are written down is incidental. It's the same factorization. 2x plus 5, 2x minus 3 is the factors of that polynomial. Now, granted, let me repeat this. I'm not a fan of AC rule. However, I do use it on occasion. But if I were looking at this one over here, I probably would still do this by trial and error. What do I mean by that? I look at the 4x squared, and I'd probably say, maybe 2x and 2x. Not giving it much thought, by the way. Look at the 15, probably saying 3 and 5. Again, if it doesn't work, I try again. And looking at it, 2x times 2x is 4x squared. 3 times 5 is 15. I got to get a negative number in the end. Internal number is going to be positive. And kind of looking at it, I'm going to say this over here looks like the most likely outcome for me. I would check it. 2x times x is 4x squared. 2x times 5 is 10x. And minus 3 times 2x minus 6x. And you certainly get minus 15. Does it give it back what we want? 4x squared. We do get the 4x here. We get the minus 15. And again, no matter how I factor the problem, I'm going to be getting the same answer each time, which is 2x minus 3, 2x plus 5. And that's a good point. Factorizations are going to be unique. Thank you.